Hello, today I will solve a question of partial differential equation of GATE 2024. So the question is, if u be the solution of del u del t minus 4 del 2 u del x2 equal to 0, where x is in the interval 0 to 1 and t is positive, also with the initial conditions u02 equal to u1t equal to 0 and ux0 equal to sin pi x, also define gt equal to integration 0 to 1 uxt whole square dx, then which of the following is true? We have to find out. So if you see the options carefully, then all about g is decreasing or increasing in the interval 0 infinity and others about limit t tend to infinity 0 to. So we have to find the value of gt when t tend to infinity. So let's start the solution. So as you can see that this is a heat equation. So if we compare with the standard heat equation ut equal to c square uxx, where u0t equals to ult equals to 0 and ux comma 0 equal to f of x, then where 0 less than x less than l then we know that actually if you compare with the given equation, then c square equal to 4, l equal to 1 and fx equal to sin pi x. So c square equal to 4, l equal to 1 and fx equal to sin pi x. Then by the standard notation we know that uxt will be summation n equal to 1 to infinity bn sin n pi x by l e power minus c square n square pi square by l square. Oh, this is n square by l square t, where bn can be calculated by 2 by l integration 0 to l sin n pi x by l into f of x dx. So since we have c square equal to 4, l equal to 1 and fx equal to sin pi x, applying those we can find the value of uxt equal to summation n equal to 1 to infinity bn sin n pi x e power minus 4 n square pi square t, where bn equal to 2 by 1 because the value of l is equal to 1 and integration 0 to 1 sin n pi x sin pi x because fx equal to sin pi x dx, and if we calculate this, then 2 into integration 0 to 1 sin n pi x sin pi x dx will be equals to non-zero value 1 by 2 only when n equal to 1. We all know this, that this will be non-zero when n equal to 1 and otherwise it will be 0 when n not equal to 1. Because we know we already have this result. You can see the result that integration 0 to 1 sin m pi x sin n pi x dx equal to half if m equal to n and 0 if m not equal to n. Okay, so putting these values, we have uxt equal to sin pi x e power minus 4 pi square t, because n equal to 1 only gives the value of bn non-zero. So now gt equal to integration 0 to 1 uxt whole square, and already we obtain uxt equal to the above value. So if we put sin pi x whole square e power minus 8 pi square t, if we put whole square and then dx. Now as you can see, e power minus 8 pi square t is independent of x, so we can take this in outside. So e power minus 8 pi square t 0 to 1 sin m pi x whole square or sin square m pi x. So we can take 1 by 2 outside and 2 multiply then the value will be e power minus 8 pi square t into 1 by 2, and if we integrate then it will be x minus sin 2 pi x by 2. Oh sorry, this will be yes, sin 2 pi x by 2 pi 0 to 1 equal to integration e power minus 8 pi square t by 2, and if we put the limits 1 and 0 then it will be ultimately 1. The whole value gives 1. Now you can check that g is decreasing because we have e power minus 8 pi square t, and also we have to calculate the value when limit t tend to infinity. Then limit t tend to infinity gt is equal to limit t tend to infinity e power minus 8 pi square t by 2, and if t tend to infinity then e power minus infinity will goes to 0. So you can check that limit t tend to infinity g2 equal to 0, and also g is decreasing on 0 infinity. So option A is correct option.